All righty. So I decided just to do this problem today with y'all. Um, I think seeing how useful math is in an application, a real world application, is makes it a little interesting. You know, I think it helps you understand a little bit better. And you guys have probably already noticed that we do a lot of real world applications of math because for me, that's what makes math fun. Hopefully, you feel the same way. So, we have a wood frame here that we're using, and you might have seen this in your own life, to pour concrete in, just like when you do this with a sidewalk, right? But the thing is, the concrete is kind of dense and heavy, and it'll probably push these boards and make the frame become warped. So we need these steel wires for the diagonals to make sure the frame, the woods don't get bulged out or get warped, because that would be a bad thing, right? That would make the sidewalk all yucky and crooked. All right, so we're going to use these 12 gauge steel cross wires. Okay, now we need to make sure we have a little bit extra on the end because we're going to attach it to the corners. So when we figure out what the length of these diagonals are, we're going to have to add half an inch to each side so that we'll have something to attach to the corners, right? Okay, so given the information that they tell us in the second sentence, the length is 1 meter greater than its width. That's important information. Knowing that the perimeter is 14 meters, more important information. We're going to eventually find the sides of the rectangles and then use the Pythagorean theorem to find the diagonal. And then once we get the diagonal, we're going to add an extra half meter to each side. Okay? So just a verbal summary of what's going on. And I drew this on the board too to look at. So again, you know, if we have something that can slant, that's not good. So with a box, you know, what they usually do is they have some kind of thing here where it slips into each other, and that makes the box more rigid, right? It's not as easy to slant. Now, if I take that down, now it's got no support, and it's going to go whoop, 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 right? We don't want that. So we're going to use the steel gauge wires to do that. So setting up the problem, the length is 1 meter longer than the width. That's why I put W plus 1 here. And opposite sides of a rectangle are equal. And we know the sum of those sides are going to equal 14. Right? So let's count. Let's see. 1, 2, 3. There's 4 W's. And there's plus 1, plus 1. So that means plus 2. So you solve that equation. Then once you solve that equation, W will be this number for the triangle that we're using to get the diagonal, the right triangle, and then W plus 1. Again, once you get the W from this equation, then this side of the right triangle will be the W, and that'll be the W plus 1. And then you can use the Pythagorean theorem to find C. Now, there may be something you notice when you get the W and the W plus 1 that you can use. But again, once you get the diagonal, then just add 0.5 and 0.5. That way, the wire that you use has something you can attach to the corner. And, you know, you want to be a little precise here because steel gauge wire is expensive. You know, if you use too much, you're going to have stuff that you don't use, you're going to have to throw away, right? So if you use too much, you're going to have to cut off a little bit because it's too much, and then you got to throw that away. It never gets used. So we use math so that we can get exactly how much we need, and that way we are able to use all of the steel gauge wire without having to throw any away, right?